probably seen the pictures, right? These incredible, almost otherworldly-looking homes made of old tires and glass bottles, promising this totally self-sufficient life. But you have to wonder, behind those amazing photos, are they a real blueprint for sustainable living? Or is it all just eco-fantasy? Well, today, we're going to dig into the actual data and find out. So, what even is an Earthship at its core? Well, think of it as a type of house designed to be completely autonomous. The whole idea, from architect Michael Reynolds, was to build a home that functions entirely off-grid. It's built with recycled and natural stuff, most famously those tires packed with earth, and it's designed to handle everything on its own: heating, cooling, water, even its own waste. And the claims are, well, they're pretty bold. The official website calls it the epitome of sustainable design. And get this, it says no part of sustainable living has been ignored. Wow. That is a really high bar to set. So how on earth do you even begin to test a claim that huge? Well, that's where we move beyond the marketing slogans and get into the actual science. To get a real answer, you can't just go on feelings. You have to look at serious academic research to see how these buildings actually perform in the real world. And lucky for us, we found the perfect source, a super comprehensive Ph.D. thesis that's dedicated to this exact question. So this isn't about anecdotes or what people think might be happening. This is about hard data and analysis that's been properly scrutinized. So yeah, we are diving deep into Martin Freney's doctoral research from the University of Adelaide. And his whole thesis really sets out to scientifically test two massive claims. First, that Earthships can provide passive comfort in pretty much any climate. And second, that they're the most sustainable building design out there. And the way this study was done is actually pretty brilliant. It used this three-pronged approach. First, what's called a post-occupancy evaluation, or POE, which is a fancy way of saying they surveyed residents and actually monitored the conditions inside the homes. Second, they used computer simulations to predict how the design would hold up in different climates. And third, they did a full life cycle assessment, the whole shebang, to calculate the total environmental impact from the day you start building to the day it's torn down. Okay, so let's start with that first big claim, comfort. This is one of the most famous promises of the Earthship, right? The idea of a house that keeps itself warm in the winter and cool in the summer all by itself. No furnace, no AC. The research zeroed in on the absolute perfect test case, Tahoe, New Mexico. I mean, think about it. It's a high-altitude desert. You get freezing cold winters and really hot summers. If an Earthship can work there without modern heating and cooling, that's a huge testament to the design. And the hard data they collected is just fascinating. The research team literally put sensors inside and outside a bunch of Earthships and Taos, and the results are just crystal clear. While the temperature outside is on this wild roller coaster ride, the indoor temperature just stays incredibly stable, right in that sweet spot for comfort. Now, this data lines up perfectly with what the people living there actually felt. The thesis concludes that yes, the Earthship does provide thermal comfort with active systems, and, this is the crucial part, the residents themselves said they were very satisfied. So, the verdict on claim number one is pretty straightforward. It absolutely holds up. The whole design of the Earthship, from the tire walls and being built into the earth to that sun-facing greenhouse, it all works together as a system to create a passively stable and really comfortable home. But that brings us to the second, and you could say even bigger claim. Is the Earthship really the top dog of sustainable housing? What's its total environmental footprint actually look like? To answer this, the research used that third method we talked about, the life cycle assessment, or LCA. And this technique measures, well, everything. The impact of getting the raw materials, the construction itself, all the energy used during its lifetime, and even what happens at the very end. And you know what? This is where the story gets really, really interesting, because the LCA found something totally unexpected. It turns out it's not as simple as just saying, hey, using old tires is good for the planet. There's a twist. So here's the first part of that twist. If you look only at the upfront environmental cost of construction, just the building phase, the Earthship's protective shell, its thermal envelope, with the greenhouse, the packed earth, the concrete, it actually had a higher initial impact than some other building types, like mud brick. But, and this is the absolute key, the most important part of understanding the Earthship, that's only a tiny piece of the story. This chart here shows a home's entire lifetime impact. For a normal house, construction is just a small slice of the pie. The really huge slice is the decades and decades of energy it's pulling from the grid for heating and cooling. Now look at the Earthship. It's the complete opposite. Yeah, a bigger upfront slice for construction, but then a nearly zero slice for operations because it powers and conditions itself. So is the Earthship sustainable? The research gives a resounding yes. But the biggest environmental win, the real genius, isn't actually the recycled materials. It's the design that leads to a near-zero operational footprint over its entire life.
Okay, so after putting all the hype through a rigorous academic test, what's the big takeaway? What do Earthships really teach us about building for the future?
The genius here isn't one single thing. It's not just the tires, it's the entire system. The research makes it so clear that the passive solar design, the greenhouse, the earth sheltering, they all work together to create that incredible comfort. And that efficiency is what allows the simple off-grid systems to handle all the power and water needs, which then gives you that tiny life cycle footprint. You see, it all connects. And that really leaves us with a final, kind of powerful idea to chew on. Maybe the most radical thing about the Earthship isn't the materials it's built from, but the whole lifestyle it makes possible. It suggests that the future of sustainable housing might be less about what we build with and a lot more about how our homes are designed to completely reshape how we use energy, water, and resources every single day.